Chapter 2 deals with matter. First, we're going to look at the properties of matter. Matter can be divided into extensive or intensive properties. Extensive, by definition, depends on the amount of matter in a sample. So your mass and your volume, those will change as the amount of the matter changes. So those are extensive properties. Intensive properties do not depend on the amount of matter in a sample. So I've given you a couple examples of intensive properties here. Hardness, density. The density of water doesn't change regardless if you've got a small amount of water or a large amount of water. The color of a substance is independent of the amount of matter. Melting point, boiling point, those do not change regardless if you've got a large amount or a small amount of matter present. So matter can be divided into extensive or intensive properties. Some other properties of matter are physical properties and chemical properties. Physical properties are properties that can be measured without changing the composition of a substance. So for example, I can determine the color of a substance without changing the composition. I can determine the density of something. I can measure the density of water and it will still be water, so I don't have to change the composition. I can determine the conductivity, how well it conducts electricity. I can also determine how malleable it is, how easily it is to be flattened into sheets without changing the identity of a substance. A chemical property, on the other hand, is a property that a material exhibits as it undergoes a change in composition. So for example, carbon, as it burns, we can observe that chemical property as it undergoes a change in composition. There are three states of matter: solid, liquid, and gas. A solid has a definite shape and volume. You can't compress a solid. The molecules are very close together, so those solids are incompressible. Liquids have a definite volume, but you can change the shape of a liquid. And with liquids, if we think about on a molecular level, those molecules are very close together, so those cannot be compressed either, just like solids, because those molecules are very close together. The only difference between a liquid and a solid is a liquid has the ability to flow and to change shapes. A gas has an indefinite volume and shape, and so gases will take the shape and volume of their container, and I can compress a gas into a smaller volume. So if I were to take the air inside this room and compress it, I could do so because air is a gas. Vapor is not the fourth state of matter, but a vapor is currently in the gas form, but it's a liquid or solid at room temperature. So vapor and gas are sometimes used interchangeably, but gas and vapor do, on the scientific level, mean different things. So there are three states of matter: solid, liquid, and gas. Now we're going to look at physical and chemical changes, and we'll spend a lot of time on physical and chemical changes in order to determine if it's physical or chemical. A physical change changes its appearance, so it looks different, but the composition is still the same. There are two types of physical changes. There are reversible and irreversible physical changes. Reversible physical changes, melting, freezing, boiling, condensing, these are all state changes. Changes from a solid to a liquid, or liquid to a gas, gas to liquid, and so forth. These are state changes. Irreversible physical changes, like cutting hair, cracking an egg, it's still the same substance. It does look different, though. A chemical change, on the other hand, is a transformation into completely different materials. And with a chemical change, you're looking for descriptive words like burning, rusting, decomposing, corroding. Those are indications of a chemical change, those descriptions there.